Good evening, everyone. Welcome to 7th live session for the course Usability Engineering. My name is Neelarnab Dutta. I'm a PMRF fellow from the Department of Design, IIT Guwahati. So in this particular class, I'll be discussing about key concepts from week 7 lecture videos. And this session will be a bit interactive in nature. So please make use of the microphone or the chat box to message me in case you have any doubts. Since the nature of the assignments are objectives, so this session will be more like a problem. Instead of problem solving, this session will be more informative in nature. So I'll be trying to clarify your doubts, which will be helping you in solving the assignments. Okay. So let's start with some recap from last few classes. So in the last 2 weeks, we have studied about various user study techniques. Prior to quantitative methods, we discussed various qualitative user study techniques like interview, then think aloud protocol, survey, etc. etc. Now, some of these were activities which helps you to understand users' attitude. Some of them are behavioral in nature. For example, contextual inquiry is the one which allow you to visualize a particular scenario where user is involved and we can see user behavior. Then there are few techniques where we can collect information about cognitive processing that user might have to do while performing some task or while operating some devices. So there are different aspects of user study that we try to cover in qualitative user study techniques. Similarly, in quantitative techniques, in the last week lecture videos, we have discussed about techniques like quantitative usability testing, web analytics, A/B testing, etc., which are again quantitative in nature. So difference between qualitative and quantitative studies was also discussed. So I will again clarify this. So in terms of data types, quantitative study will provide us data which are either numerical in nature or they have some number associated with it in terms of grouping or in terms of scale. So we can represent the outcome of a quantitative study in the form of numbers. Okay. However, in qualitative study, we collect information about people's attitude or behavior, which later we synthesized using techniques like thematic analysis, etc., to identify key concepts or key themes from the user study data. So the nature of the data types, the output data types are different and also their uses are different in research study. Okay. We also discussed about external validity and internal validity. So external validity means when you do a user study, whether it is qualitative study or quantitative study, you make sure that the scenario which is used for qualitative study for the study is an exact replication of the scenario that is present for a large group of population. Okay, so the mini study where you use probably a small sample of the big population should be of similar nature and also the scenario or situation in which a particular study has been carried out should match the external scenario where actually event occur. Okay, so that is meant by external validity. Similarly, internal validity means you make sure you do not consider samples from any particular or any specific group so that you do not get any bias information as an output. Okay, so in order to have good internal validity, you need to make sure you use a heterogeneous group where there are uniform distribution of different population type for your study. Okay, that is what is defined by internal validity. So that is an example. Then we discussed about various synthesizing techniques. So one of the technique was persona creation. We also discussed about various guidelines, how personas were created. So persona help us in remembering particular user. Okay, so this helps in remembering user. We also can relate the user by looking at the needs, the desires, the objectives of the persona. So what persona represents is a population. Instead of one single person, a persona represents a population, a specific population, their needs, their desires, and their various actions which we try to capture for our design purpose. Okay, so that is what is called persona. After that, we also learned about various mapping techniques. For example, we learned about empathy mapping, which was using the 4 quadrant, and we try to map what users see, what they feel, okay, how they act, etc. Similarly, we mapped customer journeys. Okay, then we mapped experiences. Then also we try to recreate particular service based on experience maps. Okay, so these are various mapping techniques we learned previously. Now, prior to that also we have learned few mapping techniques in our qualitative user study, as well as in the previous class we tried mapping these various user journeys, user profiles. But if you see, the nature of these mappings involve both physiological activities, that means actions, interactions, communication, etc. And also there are a part of uh, interactions which are cognitive in nature. Okay, so these maps are not very efficient to actually represent the cognitive processing, the cognitive load that a particular user has come across, because these maps are not efficient in representing those. Though we can visualize and represent particular cognitive action in the particular area, and we say that that's a break point because of that particular specific cognitive issue, but these maps are not ideal to represent the cognitive issues that occur during a task operations. Similarly, when we used the techniques like think aloud protocols, what we tried to capture was the cognitive processes, okay, while the user performing any task by speaking aloud the kind of mental processing the user is going through while performing the activities. Okay, now these are the ways how actually qualitatively we can capture information about cognitive processes. Now think aloud protocol, tapa, allows allow you to capture qualitative information about cognitive issues. Now there are also quantitative techniques which are also helpful in analyzing cognitive processing, cognitive issues while doing activities. And in this particular class, we'll be discussing that. So let's start with the concept called cognition. So what do you mean by cognition? Okay. So cognition are mental actions, processes that involve acquiring, okay, maintaining and understanding knowledge. Okay. So remember these three things: acquiring, maintaining and understanding what knowledge through thoughts, experience and the senses. So that means you have ways how you do mental actions and processes, which are thought process, experience, that means while using or doing certain action, then through senses, which are your visual, auditory, etc. senses. So these are the three different ways how you capture information, and then while acquiring, maintaining and understanding knowledge, you do mental processes. Okay, and that is what is defined as cognition. Okay, now the primary activity in any cognitive task, in cognition, is thinking. Thinking means coming to a decision. Okay, it can be reaching a solution, it can be forming a belief or developing an attitude. For example, imagine this particular scenario. So you have a war scenario where a medic guy, so he is probably the medic guy, that means the doctor, who is trying to help a wounded soldier. So now let's try to list down all the cognitive processes that might be occurring inside the head of this medic guy. So what will be various cognitive processes? The very first task will be uh, identify wound site. So maybe there are various different sites where the person got injured. So he's first trying to identify various wound sites. Okay. Next, trying to understand the wound type. Okay. That means based on various wound sites, the medic guy is now evaluating the particular wound site, and he is trying to understand what kind of wound occurs at various locations. For example, some wounds may be very deep, some ones are superficial. So depending upon the types of wound, now the person is trying to evaluate the wounds. Okay. Next, he is now planning for treatment. Okay. So he is probably a knowledgeous guy and he know various treatments. Okay, and what he have is something like this particular device he have in front of him, and but this device is capable of providing all sort of therapies. But now this person has to actually plan various treatments for various wound sites. Okay, so that's again another cognitive process. Sorry. The fourth cognitive process probably will be to look for the therapies. Okay, so look for various therapies in the device, right? And once he understand the device interface and various, he decided the various therapies, he will use the device therapy. So he will probably use particular therapy number one. Then he will be navigating through the interface and will be setting various features. Then probably he will start the therapy. See, the entire process of using this particular device not only involve a physical action, few physical actions, but also involve five measure cognitive processes. Okay, and that's what we need to understand while designing a UX solution, because the mappings that we have learned in our previous classes are mostly related to physiological actions or activities or communications, and here we are discussing about various cognitive tasks that actually the user has to go through while using a particular device or interface. Now, qualitatively, how we capture those we already learned using TAPA, etc. And we'll be discussing here in this class how we'll be using quantitative techniques, but that will be at the later stage in this particular class. But before that, we have to actually understand what are various cognitive issues, what are various theories involved with cognition, and we actually need to understand what actually we are trying to capture as cognitive processes while using devices or interfaces. Okay. So what we understand that as a designer, we need to consider frustrations, issues that affects decision making. See here, the particular medic guy is actually trying to make certain decisions. Okay. Now, if while making those decisions, if there are disturbances or if there are frustrations, okay, because of bad interface, then probably we need to work on that. Similarly, solution synthesis in this particular case will be like identifying the therapies. Okay, similarly, forming behavior and develop attitude. So these are probably which are habitual in nature, but as a designer we try to identify various frustration and issues that actually affect the cognitive processes of decision making, solution synthesis, forming behavior and developing issues. Okay, and once we collect information on that, we then only able to understand the user requirements from cognitive perspective. Okay. Okay, so I hope this is clear. So let's proceed to next. Now there are various types of cognitive processes. So we in our brain we have different senses, and we these are like inputs through which actually we get information. There are also input output devices which actually provide output. Okay, so we have different senses. Okay, so we have auditory, visual, etc. Now, based on uh, various attributes, we can classify the cognitive processes into these various categories. Okay, the first thing is attention. So, attention is about focusing on specific stimulus. So, attending the mind into something is what is defined by attention. So, then this is like stimulated by stimulus like visual information or auditory information. Okay, so we need input data to be processed. We have five senses, which are vision, audio, smell, and touch, etc. And these stimulus actually allow us to focus our attention in a particular processing. Okay, so this is one of the processes of cognition. Okay. Then second is language. So processing language is another cognitive processes where we try to understand and we try to communicate in order to understand information and also to carry forward communication for deeper understanding. Okay, so language processing is also one of the cognitive process. Similarly, learning is also a cognitive process where we understand new things, we take in new things, synthesize the information, and then we collect those information, the data as a knowledge, and integrate to our prior knowledge. For example, when you are not knowledgeous about for example YouTube video surfing, but you learn those and then you add those to your past knowledge of web search. Okay, so this is how you gain experience, and later this reduce your cognitive load when actually you same information is used for learning. Okay, so this is how we collect information, also we process information. Then memory processing. Memory processing means when we are exposed to any new devices or any interfaces, we try to capture information first in the form of short-term memory, and we try to see various patterns and we try to store them in our long-term memory as well as short-term memory for quick retrieval or long-term retrieval. Okay, so these are also various mental processes, cognitive processes. Okay, then perception. So while taking information as a part of stimulus, we are also trying to understand the senses they are making and utilize the same information as a response to interact with the world. So perception is again when we collect information. Now that is data. Now data and information are two different things. So you have 10,000 data, for example. So someone is speaking in front of you. That means the person is responsible for providing data, but taking those data is up to you. Now when you take only 500 of those information, for example, then you try to see various chunks of informations. Okay, you try to see various concepts in those in the data. Okay, and you only is capable of using storing those chunks of information into your short-term memory. Okay, so this is how we create perception about the information that has been provided to you. So this is what is perception. Next is thought processing. Thought processing is again like thinking, critical thinking, or problem solving thinking, where you try to make decision, evaluate things, and also we try to do higher order reasoning. For example, in the case of that soldier, that medic guy, he is trying to evaluate wound types because the information he is getting is only visual information, right? So from the wound side, he is getting visual information, but in his head he is trying to analyze the wound site. He's trying to do reasoning which particular wound or therapy needs to be provided. So all those problem solving, higher order reasoning and decision making take place inside that person's head, but the data type is only visual information. So again, thought processing also is one of the cognitive processes. So these are the six different common cognitive processes that we come across in our everyday life when we interact with any devices or any interfaces. Okay. Clear? Okay. Next, we will be discussing about cognitive load and the theory behind it. So, you should know one thing, that we have two main memories. Okay, one is short-term memories, which is also known as working memory, which are limited in capacity. The other thing is long-term memory, which is more like a storage hard disk, and it has unlimited capacity. But you need to understand one thing, as I previously said, not all information or data that has been provided to you get stored in long-term memory. So your brain can process only few information initially, and it put it in your short-term memory, and then when it sees any sort of pattern, then only it put that in their long-term memory. So that particular pattern is what we call a schema. So you have so many information that has been provided to you in a short span of time, when it's called working memory. When you are working in a particular task or any activities, what happens, like you will be provided with so many information. Now out of this so many information, probably few will be only considered as input by your in your brain, and the others you rejects because those probably are not very familiar information, or sometimes you probably overheard things, so you may lose information that way also. Now out of this, what happens, like you try to correlate various concepts and try to create various chunks of information. Like out of these many data, we have three main information. For example, then one is probably this, and the other is this, the third is this. Now, if we can correlate this data and then we try to identify some logics of the data and their relationship, probably that is what we call a schema. And these schemas are easy to store in long-term memory, because retrieving those information is easy because you have a particular schema of also information retrieval. That's why not all data that has been provided to you as initial working information gets stored in long-term memory. Okay, but while considering cognition, we need to discuss both of these two types of memories, because cognitive load mainly occurs when there are limitation happen in these two memory types. Okay, now working memory types uh, capture information using two independent systems which are inside us. Okay, so one is phonological loop, that is similar to auditory senses, that is what we hear. Now when we make any devices, so if the device actually interact with the user with voice or speech, so our auditory system actually works independently and it directly process the information and put it in the brain. Similarly, when you the other type of information processing system what we have is the visual spatial sketchpad, where we try to uh, capture visual information and try to actually analyze the information in the form of vision as well as spatial positions in the form of a sketchpad. Okay, this may be just position or maybe the form, the look, feel, etc. So this can be also text information. So we either is able to uh, process visual information or audio information. Okay, mainly when we deal with interfaces. Now you can also ask like, okay, what about the tactile interfaces? See, tactile interfaces also is again auditory. When you touch something, okay, you can actually touch a button, but the feedback you get is either in form of visual information or in forms of auditory information. So finally you confirm that button got pressed is either with visual information that okay, button got pressed, or it may be auditory information that okay, there is some sound comes when you actually press a button. So overall your information is processed by these two independent system that is actually inside us. Okay, now as a designer what we need to consider is that as a learning experience, okay, in any device interface, if the ability to process information through this system reaches zero, that means no matter how intelligent that particular person is, but his ability to process information through these two independent systems is reaching zero. That means you are not able to recognize visually what you are doing, or it's getting overloaded, okay, because a lot of visual informations are there, or the kind of information that you are getting via audio information is either nonsense or either it is overloaded. Okay, so for both the two cases we call it as a high cognitive load state. Okay, and we need to make our systems free from such cognitive loads, okay, where a user uh, get enable, like he get a difficulty in actually information processing from the perspective of visual processing or audio processing. Okay, now there are three types of cognitive load that commonly occur across various interface design. One is extraneous cognitive load, which is associated with instructional design. That means the way you have, for example, this person is looking at an interface and the way you design the interface the way you created the elements or you created the information is not correct. So it's called instructional design. So if there are issues with instructional design, then it is called extraneous cognitive load. Okay. Now, if there are issues with normal processing, for example, when information is there and the person has to actually put some cognitive load in actually processing the information, and while constructing the central themes and connecting the ideas into some schemes, if he is facing such difficulties, then that we call German cognitive load. The third kind of cognitive load is intrinsic cognitive load, which is basically those, this happens when there are inherent complexity associated with the content. For example, from knowledge perspective, if the content which was represented in an interface is really complex and it cannot be solved by just redesigning the instructions, then those content we call as inherently complex. That means the user is unable to understand the concept, the topics. Okay, so those are called intrinsic cognitive load. For example, if a mathematics guy have to study a biology subject, we believe that is what I mean by inherent complexity. So the subject area is very complex for both the subject areas are complex for normal person, but for a mathematics guy, probably biology is more difficult. Similarly, for the biology guy, mathematics is very difficult. So these are called inherent complexities. Okay. Now we try to minimize these three types of cognitive loads by reducing inherent complexity by clarifying informations which are intrinsic or inherent complex in nature. So you try to provide more help and documentation and try to clarify useful information in the form of images. Similarly, this is also can be solved by instructional design, and the initial part, which is extraneous cognitive load, can be always corrected by providing information in a correct way, which is called as instruction design. So the another similar concept that we have to consider is information processing theory. So, like cognitive theory, cognitive load theory, which is mainly based on the kind of memory you have. So it considered the memory you have and the complexity of information or instructions. Okay. The other theory, which is about information processes, say that it discussed that there are various stages of information processing. For example, the information is processed in a sequential manner. For example, first you get exposed to a information. Okay, for example, for that military guy, he is first exposed to the visual information about the wound site. Okay, now after that he pays attention. Okay, now this attention processing is also information processing, because now he is trying to evaluate the wound with great attention. Then comprehension, that means when he understand, he now can understand and elaborate what's actually happening at the wound site. He come to a point of agreement. Okay, and then it's all mental operations, and then retention. So these are various stages of information processing. Now, information similar to cognitive load, okay, which is more like limitation of our memory. Informations, okay, is also related to our memory. However, it consider the perspective from from the memory, but based on the content what is provided. For example, sensory memory, it tries to define the information that is screened for initially as a part of um, as a as a part of screening information to the user. Okay, so that means there should be some way how these informations needs to be uh, designed. Okay, so there should be proper way of designing the information so that this should not actually provide sensory overload, okay, in for information processing. Similarly, working memory, which is again short-term memory. Now, in short-term memory, what happens? We deal with real-time information. Okay, so we have very limited working memory. For example, we hardly can actually capture information, which is 5 to 9 information sucks at one go. Okay, so for a very small span of time, within a very small span of time, we can hardly process information of 5 to 9 different chunks. Okay, now we need to understand, like when we are trying to provide information, okay, the way the information is displayed, okay, and changed in an interface has to do with our working memory. So though the concepts that we discussed in the previous slide, which is about cognitive overload because of different types of cognitive overload, now these concepts are also very similar, but here we are considering the perspective of information processing. See what's happening, the nature of information that actually we need to process at real time is very fast, and also there may be changes in the visual information or in the audio information which the user might not have previous exposure. So that's why the user, in a novice user who is not exposed to a interface, for him processing limit is probably something around 5 to 9 information chunks for over a very small uh, time frame. So we need to manage such information. Okay, how much in different information we need to visualize, we need to show to the user, and at what frequency those displays needs to be changed. Okay, so similarly, long-term memory. So these are again considered as permanent memory. And while information design, we need to understand that when you design the information, you need to make the information logical in nature, so that the various informations that you put in the working memory, that is as a short term, have some relationship, have some logics in between, so that the information now fall into some sort of schema, and that actually transferred into long-term memory. So from information perspective also, we need to consider um, the cognitive issues, and how we can reduce such cognitive loads. Now comes the concept of mental model as well as conceptual model. Okay, now I think previously I have discussed about these two topics pretty much, probably in every lectures, and we have not gone in great detail in these two topic areas. Now in this particular lecture, I'll be discussing about what is mental model and what is conceptual model. So mental model defines the user's underlying perceptions from past experience. Okay, for example, if you have a application which is new to you, okay, and you are a first time user of this particular applications, you try to understand the interface, you try to recognize the visual information or the audio information based on your past experience. So this is what is defined as mental model. So we have some sort of previous exposure, previous understanding of systems and user interfaces. That's why when we see things, okay, we interpret first things based on our own past exposure and past experiences. This is what defined as mental model of user. The conceptual model, on the other hand, is what the designer planned as a solution based on user needs. Now, based on user study, the designer probably has come up with a specific solution for him. Probably it is the best solution to meet the requirements of the user. So those includes the hierarchy of information that has been put in a website, or probably the way the concepts are logically grouped in his websites. All those comes under conceptual model. However, this is what is this designer's interpretation of user's mental model. Now it is very important that there is a match between these two models in order to achieve a good adoption and of a new user interface. Okay, if there are mismatch of the two mental models of a user as well as the conceptual model of design of the designer, what happens, the design will not get diffused or adopted by a user. Okay, and that is what we'll discuss later as gulf of execution and evaluation. Now here we try to understand what the mental model of a user actually try to define. Okay, what actually mental model uh, tells about the user. Now in real world, okay, the mental model actually start with perceiving the state of the world, which means what we actually see. Okay, so here what we see is the screen with a application. So this is the state of perceiving the real world. Now the next thing what actually goes into the mind of the user is interpreting the perception. That means what actually this person actually have seen, he try to understand that what he is seeing. Okay, so this happens every time when you expose to a new interface. When you do not have any past experience, you try to process things from these uh, via these procedures or steps. Now you try to evaluate the interpretation. So these things happens inside your head, and you try to first perceive based on what you see, then you interpret what you see, and then you try to understand that what this particular system do, so which is called evaluation. And then you probably try to establish your goal with this particular interface. Okay, now after establishing the goals, what you do, you try to plan your actions, okay, based on your past experience. Okay, now that is what particular action or aim or objective you want to do using that particular interface. Probably that interface may not be made for that particular task which you have assumed, and after that you plan for the sequence of actions that you will be going to follow, and then you try to execute. Okay, now this mental model, okay, this particular way the particular user thinks, if it matches exactly how the designer planned the things, this is a good thing. I mean, this is what is desired. But if these things does not match, what will happen, a desired solution which is desired for the user um, is not going to come from a bad conceptual model of the designer. So probably there is a solution that has been designed by a designer, that has been provided to the user based on his understanding of user's requirement. But if it does not match the user's requirements, or it does not match the user's mental model, this is not going to be accepted by the user. So this is what we try to define as mental model as well as conceptual model. Clear? Okay. Now the conceptual model have various elements to it. So the designer tried to provide the information, his understanding of the user requirements in the form of these various elements. One is information architecture. So when you are designing a particular website or any interface, information architecture defines the way the information will be provided. So the hierarchy of information. So if you call it, so if you see a website, you have the hierarchy of information. If you call it a device, you also have hierarchy of information. So all the information may not be visible at one go, but the way the information has been arranged is what we define as information architecture. Now the way these specific levels are arranged by a designer is a part of designer's conceptual model. So how different areas being grouped and structured. The other elements that is a part of conceptual model are terminologies. So when we use various levels for defining the key concepts, we need to make sure that we use familiar terms, okay, so that those can be easily recognized by the user. Now, if we use unfamiliar terms, it will not be a match to the mental model of the user, and then that person will not going to understand. For example, instead of forget password, if you say t- password not known. Now, if you do not put that question mark, probably that will not give a idea to that particular user that now I need to click this, and probably that will give me access to a new window. Okay. Similarly, content strategy are the element which actually helps in defining various concepts and rules how the information will appear to a particular person or to the interface. Okay, now you need to strategize as a designer how the information will be provided to you. Okay, the same information probably for a interface can be provided in multiple ways, and the designer has the actually the freedom to decide on what will be the opening window of an interface, and what will be the how the second window will look like, how a particular button window will look like. So all these decisions are taken care by the designer. So these are some of the elements and that we need to consider as elements of conceptual model. Channel strategy. So this means when you're creating information, are they consistent, are continuous? So for example, you may have strategies where the information will be continuous in nature, so it will be one by one, so it will be sequential informations. Similarly, you may think about a strategy where there are some sort of consistency in the information that are provided in each page. Okay, so these are again part of conceptual model. Then interaction models, that means what sort of interactions or the type of interactions you are going to use. Okay, so this is again, this is sorry, this is wrong. So here we try to define what sort of interaction we'll be using. For example, whether you will be using visual way of information, or whether you will be providing speech techniques, etc. Okay, so these are again part of various interaction models. Okay, now a conceptual model can include metaphors. Okay, sorry for interruption. So a conceptual model can include various elements. So one can be metaphors. So for example, when you design a web interface, so you have elements like swipe. Okay, there are drop boxes. So these terminologies as well as the way of interactions are actually metaphors that has been used from the real world, which represent the actual way how actually we do swiping. Okay, the Dropbox, the picture of the Dropbox is actually looks like a box. Okay, where we can put some items. Okay, so these information, these elements which are graphical is in nature as well as conceptual in nature, actually are metaphors from real world, so that these can be easily um, retrieved or understand by the user. Then we consider relationship among various concepts. So when we have various information, for example, here we have a person. Okay, so person may have a pin, and probably he have something like ask, he can ask. Okay. Similarly, account, so inquire or update. So these concepts are actually mapped under account head. Similarly, pin and ask, probably pin is something which is like the password, and ask is probably what he is capable of doing. So these concepts are actually captured under the person. So building suitable relation that actually match the mental model of a user from his past experience is very much necessary. Okay. Now, mapping concepts to actual activities. This is again when you are trying to map, trying to build relationship between various concepts. For example, person interact with the debit machine and person interact with the account. So this is how the relationship has been established. Okay. So now this is a two-way communication interaction where it defines that debit machine also try to collect information of a person, and similarly person also can uh, collect information about a system. So this kind of mapping of concepts to actual activities is what needs to be defined. Again, terminologies as discussed should be common, relatable, and it should be appropriate. So difference between appropriate and relatable is that relatable means a particular terminology should be easily understandable. For example, if I say pain, so the word pain is easily understandable. Okay. Now if I say appropriate means whether the particular symbol pain or this particular word pain is appropriate in that particular context. So when you use the symbol pain, for example, if it is a pain, okay, so using this particular symbol, is it appropriate in that particular context? So that is what is defined by appropriateness. Next is interaction types. So interaction types try to define how the user will is going to navigate or how he is going to use a particular interface. Now, whether he will be using navigation via hand gesture or via a mouse and keyboard. So all those decision making needs to be done by the designer by understanding the particular perception of the user as his mental model. So deciding interaction types is also based on mental model of user, what a particular person is exposed to. For example, see here, when we are trying to see something like that, we write like email address. Okay, now there's a tendency that the user will simply click here and type. Okay, so this particular affordance, okay, so which is probably common for various users, should be used by the designer as interaction elements to capture email addresses. Okay, so similar to that, there can be also use of drop up menus for particular selection. So the way interactions needs to be considered has relationship with the mental model of the user, how the user perceived of particular interaction type. Okay, clear? Okay. Okay, so here comes the concept of gulf of execution and evaluation. So as I discussed already, like when there is a mismatch between the conceptual model and the mental model of the user and conceptual model of the designer. So this is where we have the issue. Right now there's a mismatch, so the concept doesn't actually got adopted by the user because there is some sort of gap. Okay, this gap happens when user have limitation in understanding the state of a system, and also gap when user face in taking action to accomplish a goal. So this particular gap where the user fails to understand the state of a system or the way the particular system needs to be used, this is called gulf of evaluation. The other gaps where this user fails to accomplish task by taking proper action is called gulf of execution. Now both these are results of this particular mismatch where the conceptual model of the designer does not match with the mental model of the user. Okay, so this has been represented by this particular graphics pictorially. Now you have a physical system, which is probably your web interface or probably a device interface, and you have some goals. Now the goals probably, for example, if this is a Amazon website, and the goals is to buy a t-shirt, what's happened? You first face difficulty in understanding how actually one can buy t-shirts. Okay, you have actually tried to see the interface. Okay, so interface is provided to you. You try to interpret the interface. You try to evaluate the information and try to see how actually you can place an order for to buy a t-shirt. But if you fail to actually understand the interface as well as interpret various features, then that is what is defined by gulf of evaluation. That means this is the gap that needs to be reduced. Similarly, gulf of execution means you understood the goal, but now you try to understand the goal, then you understand the intention. Now you try to define the actions and then you access the interface. Probably you try to use some filter and select, or you want to type the uh, t-shirt name, but those features are not provided, then you will have issues in executing your task although you actually understand the goal. Okay, so this is what is called gulf of execution. Okay, now there are various cognitive frameworks available which actually enables you to understand the key issues and the key principle based on which actually you need to design a particular interface. Okay? So these principles can be categorized into various groups. Okay, the first one is persuasion. Okay, so under persuasion you have two theories, okay, principles basically. So one is picture superiority effect, which defines that human brain learns and retain information much better when it comes to in the form of images rather than words. That means when you try to design a interface and you want to provide information, it's better if you plan the information in a visual format in terms of images rather than text information, because visual information can directly be processed by your independent visual processing system. However, if you put text, so it has to go through two processing. First, the visual information needs to be processed by language model and you try to understand what has been said, then only it has been processed and stored in your memory. But the visual information can be processed independently by the visual processing system. Okay, so this is one you need to consider when you try to take decisions in reducing cognitive load. Similarly, framing theory try to uh, mention try to define that the media that is a part of an interface focuses attention on certain events. So use of media, basically use of any media like videos, images, or graphical content actually focuses attention on certain events and places them within the field of meaning. So when you are actually creating content media and you put them as a part of user interface, it helps you position the key concepts into the field of meaning. Okay, that means by manipulating the way we present information can change how user make their informed judgment and decisions. Okay, so you have so many content that actually needs to be considered when you are designing interface. Now, the way or the sequence or the schema by which you are actually positioning or putting the information actually helps the user to understand the core concepts of your interface. Okay, so this is what is defined by framing theory. So the way you frame the information in front of the user will try to use the information in that particular way to make their judgments and decisions. So there are various framing techniques like metaphors, stories, tradition, artifacts, etc., etc. Okay. The next important principle is associated with behavior. Okay, now behavior means how people act or perform in cases of certain certain cause. Okay, so one of such cause is cognitive dissonance. So when we provide two similar thoughts in an interface, two similar concepts, a user might get confused with similar information having two correlated connections or two different thought processes within the same interface. So such contradictory concepts, okay, within the same interface may create dissonance, cognitive dissonance, and this also can delay information processing within the user. So one important law we need to consider is Hicks law. So what Hicks law explains that when you provide more choices, okay, it will take longer time for the user to make any decisions. Okay, so that means we need to optimize the amount of information actually that needs to be provided uh, in the process of decision making, in process of user decision making. Okay, so if you provide more information, it will take longer time for the user to process the information. Similarly, if you put less information or less, if you give less choices, then probably that will not be sufficient to actually for the user to understand the core concept of the interface. Probably that will again create cognitive load because of lack of information, and which will limit the learning of the interface. For example, a designer who will be using Hicks law to examine how many functions you should be offer at any website. Okay, so he needs to decide on what sort of functions he needs to be provided so that user can uh, make critical decision making while navigating through the website. So here's a graph you can see here, like when you have too many options, okay, the reaction time reduces. Okay, so that means when you provide more options, the reaction time for the user to understand, to evaluate, and to take action also get reduces because of so much of information provided to the user. Okay, so this is what is defined by Hicks law. That is, more choices you present to the user, longer it will take uh, time to make some decisions. For example, if you see a remote control, which is a traditional remote control, and when you ask someone to actually switch a channel by using some channel name, it takes some time for a particular person actually to understand which particular channel name he is talking about, what is the corresponding channel number, and where is the information, how I will provide, and then after pressing the button, he also needs to look at the TV screen to see whether the information, the channel name he has typed, whether that got typed correctly or not, and then when he hit OK, then only the channel got switched. So all this processing needs to be done when you have such a remote control having so many buttons. But contrary to that, when you have very simple designs like these Apple remotes, which have voice controls. What we have is very limited. You can speak the channel name and channel name switches. However, when you have too less, input functionalities, you may sometimes face difficulty. Probably in terms of functionality, you may have limited functions. Probably this particular mobile you can use also for gaming. Also, you can use for uh, fast forwarding or changing to various modes. However, probably that much of functionality is not provided with such simple models. So in terms of functional limitation, uh, this may occur when you have actually reduced the choices very much. Okay, so we need to have a optimization between the choices we present to a user, and that will determine the time the user will take in decision making. Okay, another concept is visual design. So when you make a particular interface aesthetics, what happens is lot of minor usability issues get unnoticed. Okay, so users are more tolerant of minor usability issues when they find the interface visually appealing. Now this you can take as a positive principle, but this also can be considered as a negative principle because this may often uh, you know hamper identifying usability issues when you have a very nice and beautiful looking interface. Okay, so the, the aesthetics of a user interface may sometimes distract in the identification of usability issues. Now, another principle is related to interactions. So, one of the concept is progressive disclosure. So, when you user is actually interacting with the interface, he or she needs to be provided information which needs to be minimal to execute a particular task at hand. Okay, you should not be providing all sort of information at one go, and that may leads to cluttering of information and also leads to confusion and cognitive overload. So the way you present information to a particular to a user for some activity or task also makes sense when you plan the interactions. Now, there is a law called Fitts law, which is again useful in designing interfaces. Now, what it defines is that the time to acquire a target, okay, the time that to acquire a target is a function of distance to and size of the target. So that means the time is proportional to the distance that you need to move to access that particular feature, distance to feature, and also it is proportional to size of the target. That means when you have a large interface and if you are using a mouse and you have a cursor here, now if the distance between the cursor and that particular object is more, that means it will take more time to actually navigate between various features. Similarly, if size of that particular feature is very small, then also it will take more time to actually locate the cursor and select a particular option. Okay, so these two things we need to keep in mind while designing an interface. Now, Fitts rules, or Fitts law can be also applied at rules while designing user interfaces. So, very first rule is create larger targets. So, this is to make things visible, okay, more legible to the user. And also, what happens like when you make icons like this and your cursor only get activated when actually it goes and reaches a particular text, probably that will be not very efficient when you are trying to select a particular option. A good idea is that if that particular box or the button gets selected when actually you reach the particular button's outer profile, that is probably a better idea. So this is what Fitts rules suggest. So create larger targets. That means you make sure that the target, the selection target is bigger. Okay, so that it is easy for the users to select while navigating through interface. Then minimize cursor movements. So make sure that all the information that are provided are related, okay, to each key concept, so that you don't have to switch between different concept across the interface. Okay, so you don't have to move the cursor too much within the interface. So if you position relatable concepts or relatable features, within the vicinity, probably you don't have to move that much within the interface. Okay, avoid muscular tension. That means minimize those interactions which uh, leads to muscular tensions. For example, if you provide some actions like, you know mouse click and drag for a long slide movement, probably that will hamper this particular motion because it will create muscular tension in the hand. Okay, so for example, if you have a swipe button, and if you provide a swipe is too long swipe, probably that will bring muscular tension. But if you needs to provide a swipe button, probably try to make a small swipe button. Exploit prime pixels. So you have the boundaries in an interface, right? So try to use the edges, okay, or the diagonal points, okay, so that the user have much more affordance actually in locating your features and icons. So if you position something at the rightmost corner across the right and top edges, probably it is easy for the person to navigate. Similarly, if you put at the bottom, like left and bottom corner, it is easy for you. But if you put things haphazardly in the interface, probably it will be not easy for the user to exploit the location and to explore the location and navigate through the location. So exploit these prime pixels which are probably located at the corners or edges, and they are probably easy to access by the user. Now, another key principle that comes from the perspective of content theory. So, content is related to the information that you are going to provide in the interface. So, the first rule is called 80-20 rule. That means whatever content you provide as a part of user interface, just remember that only 20% of those features will be used. Okay, so 80% of the features are unused most of the time. So if we can put more time and more effort in developing those 20% of the features, then probably we'll have a better product rather than trying to equally develop all the informations that are part of the interface. Okay, so 80-20 rule applies that way. Similarly, the way the contents can be organized are five ways, which are commonly used by location, alphabet, time, category, and hierarchy. So these are various ways how actually you can categorize information. So when you are trying to put a lot of information, a lot of content as a part of interface, and if you want to categorize them into some levels, so these are some common levels which you can use, and everyone have good understanding of and good knowledge about these categories. So this will match the mental model of the user when you use something like that, which are known to, I think, everyone who uses a computing system. Okay. uh, okay, so in today's class I'll be discussing about two techniques which are quantitative techniques to capture mental or cognitive issues while performing any processing or any activities uh, using an interface. Okay, so previously we have discussed about think aloud protocol, which is uh, speak while performing any task, but the nature of the output is qualitative in nature. We again have to do thematic analysis to understand the key issues, but in qualitative technique, the goal is to reduce time and the number of tasks that one's need to accomplish any goal. Okay, so the primary goal of this particular technique, which is keystroke level model, is to reduce time and tasks. Okay, so we want to reduce the number of tasks for particular activity. Okay, and also reduce time. Now I'll explain how this is done. So theoretical heuristic evaluations cannot measure efficiency of an user interface. That is, we might, so you may know, like there are heuristics or guidelines defined for creating good user interfaces. So for example, visibility of system status or match between system and real world. These are some of the heuristics from Nelson's 10 heuristic principles, which can be used for designing good graphical user interface. Now, although these guidelines can be used for designing, but to verify or to compare the efficiency between two interfaces, we need to perform user testing. And the various user techniques that we were aware of only enable us to understand the physiological activities involved while task execution. So we need to know some techniques which also help us in understanding the cognitive tasks, the mental operations in task executions, and how we can consider those uh, cognitive tasks, cognitive steps uh, in evaluating various activities in a device interface, in executing a device interface. So a common use of keystroke level model is when you try to compare two design variants of a user interface. Again, we can also use the keystroke level model when we try to compare the common trend or common way how people navigate through particular interfaces. Now, the idea of operator come into picture when we talked about keystroke level model. So an operator is a elementary cognitive step. That means this is the very basic cognitive steps that cannot be decomposed any further. And you perform multiple of such cognitive steps sequentially for task execution. Okay. For example, when you say I will book a ticket in in book a ticket, movie ticket in Book My Show, what happened? Like every small cognitive step, for example, clicking the search bar, typing letter 1, typing letter 2. So like that, every small interaction that you perform is a operator. So these elemental steps cannot be decomposed any further. That means these cannot be break down into subtasks. These are the elemental tasks, and we need to first break down the activities into such subtasks and then try to understand what are various cognitive tasks that has been implied in a particular task execution. Okay, so there are 7 operators, such operators, which falls under 3 categories. Now these are the 3 categories. Physical operators, that means those operators which involve physical movement or physiological activities of the user. So for a user interface, such operator can be like key press. So K is the label for representing key press. Similarly, B is a label used for mouse button press or release. So when you mouse click the mouse and then you release, it is B. Similarly, cursor pointing task. So when you first go to a particular level, that particular task itself is a cursor pointing task. So moving a particular cursor position from here to here is represented by P. Homing, so homing is represented by H. That is when you leave a particular task or when you actually switch between mouse and keyboard, this is called homing task. Then drawing, so when you click the mouse button and then you drag or draw with the mouse, it is called dragging or drawing with the mouse. This is represented by D. So these are the 5 physical operators. Then you have mental operation, which is decision making events. And you have system response operator. That is when you perform certain activity, how much time the system takes to give a response. Okay. Now, what KLM defines or suggests is that historically, based on various research, there are some standard timing for each of these activities, each of these operators. Okay. Now these are empirically calculated based on various research, and for example, K, the average key pressing time is 0.2 seconds. Similarly, point with a mouse, so 1.1 second average time. Now these will vary when actually the size of the interface will change. However, when you try to compare two interfaces within the same display, probably these differences will not make any differences. Okay, that's why probably if for a larger display this 1.1 second became 2.0 second, probably when you compare two different designs within the same display, this will compensate. Similarly, mouse button press is 0.1 second, press and release button 0.2 second. So BB means button press, B means release. So this is only button press 0.1 second. When you put 2BB, that means it is press and release. H is again homing. So when you change between keyboard and mouse, the time that you spend while changing the two interfaces is called home. This is 0.4 second. M is mental action is 1.2. Again, mental action is also defined based on some prior research. Now this is also defined as a standard timing as 1.2 second, which involves evaluation, okay, planning, etc. So whenever you consider within a task that some sort of mental operation needs, at that time you can consider such mental operator. Okay. So I'll give an example. For example, if you need to delete a file by dragging it to a trash icon. So you have a computer window and then you have a trash bin at one location and there's a file here. And if you want to drag by clicking the mouse and then putting it inside the trash bin, so this particular activity can be analyzed using KLM. So what will be the various steps? So here are the steps. The very first task will be point to the file location. So point to the file location, that means you are moving your cursor to the file location. So this is the physical task, the physical operator. P, cursor pointing task. Similarly, press and hold mouse button. That means first press then release. So you will be considering BB. So what happens here? First you P plus press and hold BB plus drag file to the trash icon. Again P, okay, then release the mouse button P, then point to the original window which is change, okay, P. So this is the total time that is required. Now if you say there are 3P, there are 3B, and it will give you 3.5 seconds. So now this is one way how you considered both physical action as well as your mental actions. Now when there is involved any sort of mental activity, you can use in between MBB. That means the user needs some sort of mental processing, okay, cognitive processing, when you make these decisions. And you can see that by looking at the user, or you can actually ask that particular person if he needs some time to make certain decisions. So if he needs certain mental processing, you can use the mental operator B. Now the timings used in these particular models are absolute, and this actually does not affect the overall outcome, because generally KLM is used when we compare two different interfaces. Now when we compare two interfaces having different features, for example, you have a design where in order to buy a particular product you have to type, and then the item will appear here, then you press buy. The other way is actually there are drop down menus where actually you can move and select the item and go to buy. So these are two different design 1, design 2. Now these timings which are constant does not matter, because for both the interfaces you have considered the same set of values, similar set of values. For example, while typing your product name and buy, probably there will be 7 key presses, then another moving, pointing the mouse probably 2 times, and then again mouse button press B. So probably that is the way how you will interact with this interface in order to proceed this buying action. For this particular interface, probably the action will be only P plus then again 3P, okay, and that will be probably the output. Now when you considering these values, though since the values are same, okay, so you will have different output numbers. Okay, so for example, for the design one, in order to perform the same task, it took you 4.8 seconds. For D2, it took you 3.5 seconds. That means this particular design is a better design in terms of efficiency. And KLM helps in identifying a more efficient interface which is faster and which takes less number of steps. Okay? So that's the benefit of using KLM. Another technique which is also used for defining tasks is called GOMS. Now GOMS stand for goals, operators, method, and selection. Now when you, for example, for the same particular task of buying a shirt, here what we try to define first is the goal. Now the goal here is to buy a shirt. Okay, buy a shirt. Then operators will be all sort of similar to KLM, all sort of small sub steps or actions that we perform, whether it is mouse clicks or pointing or dragging, those are considered as operators. So you can consider here also KLM operators. That means these 7 operators. Methods. So for the same particular goal, probably there are different ways, okay, how you can perform the particular task. For example, one way of buying a shirt probably is typing the shirt name on the search bar, t-shirt, and then press this button, enter. So you have 1 2 3 4 5, you have 5 button press, then again pointing the mouse is 1p, then pressing search button is p, and probably you will end up in a page where you have different search. Okay, so probably here I will be calculating like, okay, the time is something like 4.5 seconds. The another way how actually you can navigate for buying a shirt is probably you go to department, When you click, it is one particular. So this is here. This is the first method. The second method is go to department. So first click department. So one button press. Then there will be a drop down menu. Select point to a particular apparel section. Go to men's. Okay, again pointing. Press men's t-shirt. Probably button press. So this is the time frame which will probably less than this 2.5 seconds. So now what happens here, like we have now two methods, M1 and M2. Okay, so GOMS allow us to a select the more efficient or select a particular method based on our own selection rules. So we can set our own selection rules. For example, we can say like we will choose the more efficient path. That means the faster path, which takes short amount of time. Similarly, this can be like, okay, less complex task. Okay, instead of more time efficiency, we can decide on, okay, the steps which is easy to understand. Okay, probably it will take more time, but it should be easy to navigate. So based on our own rules, we can actually select the final methods that actually we are going to use for particular task. Now GOMS can be used, okay, in combination with KLM to actually calculate the timings between two different methods. Okay, that means when you use KLM, okay, in conjunction with GOMS, there we will be able to identify the time requirement between, we can compare the time requirement between two methods, and also we can understand which particular task needs less amount of steps. Okay, though it does not talk about the complexity, but it talks about the number of steps involved, and also number of, like, amount of time required in executing a particular task with via a particular method. So GOMS allow us to compare a single interface, or also it can be helpful to compare different interfaces, but it try to analyze different methods, how a same goal can be achieved. Okay, similar to that, there are also other techniques which are also quantitative in nature that can be used, but for this particular course we'll be considering only KLM and GOMS as quantitative ways of considering the the cognitive issues that are involved while performing any user-oriented tasks, and how we can consider those in evaluating the interfaces. Okay? So this is how we quantitatively measure the cognitive issues and cognitive tasks, and then use such techniques to modify the design features, the methods, the operators, in order to better match the mental model of the user. Okay, so that's it for today's class. So if you have any doubt, please feel free to ask. Okay, so next class is on Tuesday in this coming week. Okay, so if you have any doubts, you can ask me in that particular class also. So thank you very much.